Good afternoon, everybody. Boa tarde a todos. Today, our seminar cycle will be in English because we have a special guest from Chile, Laura Gallardo, from the Chilean Climate Resilience Center. Good afternoon, Laura.
Boa tarde. Good afternoon. Buenas tardes.
Laura speaks a few words in Portuguese to her stays, frequent stays in Brazil already in the past decades, probably. Okay, so I will present Laura to you today. Who is Laura? For who many people I think already know her, but maybe some of our students don't. So I will present her to you, and then Laura will give us a talk about the activities of the Climate Resilience Research Center in Chile, related general and also related to air quality modeling, right? And so Laura, she's an associate professor at the Department for Geophysics at the University of Chile in Santiago. And also she was one of the founding directors of the Climate Resilience Research Center in Chile, which is called CR2. And she was a founding director between 2012 and 2019. But you are still associated to that center nowadays, right?
Yes.
Yes. Okay, perfect. So she has developed a number of different research activities with a lot of international collaboration and many publications, international publications. Her main interests are in atmospheric modeling and data assimilation, air quality in megacities, and the interaction of aerosols, clouds, and climate. Laura is a chemical meteorologist from the University of Stockholm in Sweden. No, that's where you obtained your PhD. She did her PhD in Sweden. And when she came back from Chile, she worked as a specialized, counselor on the Commission for the National Commission on Environment, CONAMA. And she led one of the pioneering studies on regional modeling, and that of dispersion of sulfur dispersion, and also copper, how do you say copper in English?
Copper smelters.
Smelters, yes, thank you, copper smelters. I'm sometimes missing the words in English. I'm much more fluent in Portuguese nowadays. Okay, so in the beginning of 2002, Laura joined the Center for Mathematical Modeling, CMM, and started to study about inverse modeling applications to reduced uncertainty of emission inventories on the city scale, and also data assimilation. And apart from that, Laura was also involved on the ideal network project for optimal network design for the supercomputing clusters. Is that right? For the supercomputing clusters?
To some extent, yes.
To some extent.
Yeah.
Okay. Also, Laura was a member of the scientific steering committee of the International Global Atmospheric Chemistry Project from 2003 to 2009, and is a member of the International Commission, ICSCGP, International Commission on Global Pollution, Atmospheric Chemistry and Global Pollution since 2006. At the University of Chile, nowadays, Laura teaches courses in atmospheric chemistry, modeling and global change, inverse modeling, atmospheric sciences, and introduction to physics. And with that, Laura, I will pass the word on to you.
Thank you very much. Boa tarde, toda gente. And that's my Portuguese. I could talk about caipirinhas as well, but that's for another hour. Let me share my screen and the presentation I prepared for you. Well, thank you a lot for the invitation. I hope it's okay. You are seeing my presentation?
Yes.
Okay.
Perfect. Then I will be talking today about essentially two things which are connected, but I'm using the opportunity to summarize some of the work we have done through the Center for Climate and Resilience Research, which is a center of excellence in Chile, and in particular, how we have experienced the connection with decision-making and policy-making over the years. And I will focus in particular over some issues regarding air quality, and I'll show you some results about that. So one part will be more about the purpose of one of the purposes of this Center of Excellence in Chile, and also about the science we are doing, and in particular, some of the issues I've been dealing with in at the center. So I'm a professor at the University of Chile in the Faculty for Mathematical and Physical Sciences, and also a part of the Center for Climate and Resilience Research, which is, as I said, a center of excellence. So let's go into the issues today. First, I will try to tell you over this image of Santiago in one of the polluted days. I will show you the reason why CR2 was created, the opportunity we use for that, and also what is the purpose, what for this institution is. Then I will stress some of the particulars of being in the times we are going through, and particularly the times that we call the anthropocene, this part of the time of the history of our humanity that's living through a period when our activities have transformed the planet we live in to such an amount that things are changing rapidly and also overwhelmingly. It's a bit overwhelming what's going on, and you know it, and we know, and I know it, and everyone is experiencing that part. Also, we will go into the ways in which this center has been trying to cross the bridges between policymaking and science, and from the side of science, how do we collaborate, interact with decision-making, and finally politics. I mean, understanding politics as a way of living together in a planet like this. Then I will go into issues that have to do with my area of expertise and climate and air quality. I will show you a few highlights of the research we do at the center, and finally a summary. First, this center is one of the centers of the several centers that Chile has been funding since the late 1990s. In fact, this center started in the years 2000, roughly, specializing at first in mathematics, biology, etc., which were quite, what I would say, well-established sciences in Chile. But the difference of this program was to look at issues and problems in science that was relevant for the development of Chile. These centers get roughly something like 1,000 million pesos per year, which, depending on the rate, it can go from 500,000 to 500,000 to $1 million in periods yearly, but in periods of 5 plus 5 years. And our center emerged under this program in the late 2011. They made a call on climate change, and we submitted a proposal in which we had combined 3 universities and researchers from many other universities as well. So we started in 2013. That's the actual start of the project. And we have been there since then. And the project is evaluated every 5 years for continuation. We are living through the second half of this period. We are now, if I recall correctly, on the 8th year. And so we are expecting to continue, but it will depend on the funding after year 2022. So the other logos you see there have to do with, I don't know, with Chile is getting, the population is getting older. So there is an interest in studying what's going on when you get older, what happens with conflicts, you know, with the Antarctic area in terms of biology, of climate change, of people living there, with disasters. We are a country we're very much exposed to a number of so-called natural disasters, energy, of course, solar energy, geothermal energy, genome, fisheries, urban development, etc., etc. So there are a number of centers, and one of those centers is CR2. The objectives for CR2 are the following. On the one hand, as any standard center of excellence, we want to better understand, in particular, better understand the science of climate, the sciences of climate, and also of resilience. Trying to understand the processes as well as the impacts throughout Chile, starting with Chile, in quite a holistic manner. So from the very beginning, we combine natural scientists as well as social scientists. Also, when we were putting together this center by late 2011, 2012, we could, I mean, the community actually dealing with science, with the science of these issues of climate change, and from any perspective, natural science or social science, we were quite few people. So one of the objectives also was to strengthen that community and making it bigger. Finally, and perhaps this has been a bit of a difference of this center, is that we wanted to collaborate with policymakers, with stakeholders in general, in trying to identify measures that would help with mitigation and adaptation to climate change, trying to build societal resilience. In a country that is very much marked by physical gradients, here in the corner, in the left corner in the lower part of the left part of the image, you can see the gradients in precipitation. We have a very dry, a desert part in the northern continental Chile, and a very wet or relatively wet area to the south, plus Easter Island and other islands in the Pacific. So it's a country marked by strong gradients in terms of, I would say, the climate. Our climate is marked by gradients. Also in the west to east, because we go from the ocean up to the high Andes with mountains above 5,000 meters. So its gradients is something we know about. Also, as many other countries in this region of the world, it's a very unequal society with strong socio-economical gradients, which also stress our vulnerability to climate change and other threats we are facing. So from the very beginning, we decided to try to make science that was to some extent, of course, curiosity driven. We are scientists, but we also wanted to make science to be useful. And this is defined in terms of these quadrants here, where you have the quest for fundamental understanding, I would say curiosity-driven science, but on the other hand, an axis that has to do with how useful that science is for making decisions, for living better in the world. And we focused from the very beginning in having a position that allowed us to have science put in this quadrant, which is called the Pasteur quadrant, in which you combine, on the one hand, curiosity-driven research, but also research that's going to be useful. And this has been something quite distinctive for us all the way since the early year, I don't know, 2012. This is essentially the same, stressing out this idea of having, on the one hand, trying to understand the climate system with humans included in its all its complexity. We understand we are dealing with a complex system. And there is part of our activities that are evaluated through standard procedures, so to speak, in which you have to make measurements, you do experiments, you do modeling, you do many things, and you translate that research into publications that are counted and evaluated. Here is this interdisciplinary community in one of the meetings, one of the many meetings we have had. But the third axis for us has always been trying to cross the bridge between policymaking and science. So from the very start, and over time, we have created different people, and now we are going into more of a plethora of different colors and combined colors of our students and the people that have been working here. Each of us, I guess, has gone through some kind of process, being able to go from your own area of expertise and combining all other areas of expertise, trying to understand things, which is symbolized in this multicolor rabbit here. So ab initio, we were dealing with crossing this bridge, and that's, as I said, is something which is fundamentally distinctive for CR2. Now, it is not easy to do interdisciplinary science, or even more difficult is to go to what we call nowadays transdisciplinary science. But to begin with, since we are dealing with a complex issue, you need to approach this issue of climate change represented here by this elephant. If you looked at the elephant just by parts in each discipline, then you are unable to get a full picture of what's going on in terms of the phenomena that are involved in this overarching area of climate change and the societal impacts and relationships, not only impacts, and the decisions that we humans make altering this world. So when you deal with a complex problem, you necessarily need the assistance or the contribution of the different disciplines, but working together, trying to understand this elephant, and not only the trunk or the tail or whatever you're looking at. So complex problems require interdisciplinary approaches, and it's more difficult, but at the same time, I would say it's extremely exciting because you learn a lot. Even old dogs start learning, because it's amazing how much you learn from looking at these complex issues from different perspectives. So that's a bit of a theory or theoretical picture of what we are trying to do. And why the second reason, in addition to having a complex problem, say the climate system, including people here in this picture showing the Earth from the moon in this picture from NASA in 1968 that one of the astronauts took in those days. The times we are going through, the Anthropocene, I like to call it the Anthropocene, is a time of multiple pressures on the Earth system that are driven by our activities to an extent never seen before. I mean, we have been around as human beings and etc. for a couple of hundred thousands of years, but over the last 12,000 years, we were having a wonderful time in a climate that was quite stable, in which we could prosper. But over the last 200 years, over a very short period of time, if you look into the whole evolution of the Earth, we have been able to put an enormous pressure of the system that's been quantified, among other things, in terms, for instance, of the changes in the biosphere. For people in Brazil, I don't have to tell you about that. And for many of us, not only in Brazil, I mean, in Chile, we are also losing, and we have lost already quite a lot of the integrity of the biosphere, and thereby also in terms of fresh water. The biogeochemical flows of nitrogen, sulfur, phosphorus, etc., is also out of limits. This red circle here shows whatever was the pressure on the planet before the Industrial Revolution, but after that we have accelerated and we are beyond limits. We are crossing the boundaries of sustainability for our world. So in that world that is increasingly subject to conflicts, for instance, for water or for clean air, subject to pandemics, subject to institutions that not longer work, that not longer satisfy the needs of people, then everything changes. And it's a world that requires, that questions the way of life we have driven, particularly the richer you are, the more you have to change your way of life. But everybody has to change the way of life. And in a way, we have to rethink how we cohabit this world, how we act as political beings. How do we share this earth, not only among us, but also between us and what we have called something different so far, which is nature. But we are a part of nature, and nature is a part of us. So we cannot live without that. And so we have to learn how to live together differently. So in a way, our intelligence should aim at developing new coexistence manners, path in this blue planet. The world is facing an epoch with no precedent. So it's difficult to learn from the past. What we did before doesn't work any longer. And many of the changes we are suffering are disruptive, surprising, fast, and overwhelming, particularly for the ways we have had so far for governing, and also in terms of our own coexistence in the world. The solutions we have to find are not longer incremental or slow. We need to have solutions that are profound, deep, and that is not trivial, that's not easy. So among the many things that have to change in the world, science also has to change. And that means that we can no longer stay in a very comfortable corner in a university doing science for the beauty of it, which is beautiful, but also we need to go into cross boundaries and to look for new approaches in order to face this crisis we are going through. But crossing that bridge between, in particular, between science, policymaking, it's not easy. It's necessary, but it's not easy. And some people call it the valley of death. You go from academia, say, and try to make a bridge with or to policy making, and in the way you may fall and lose your sanity and also your health. And there are many reasons for that, and social scientists have studied those problems for many years. And one is, of course, that the rhythms that and timings that apply to policy making and decision making are very different to those we apply and have in science. We need champions. We need people that are willing to take the risk and cross these typically weak bridges that need a lot of work to be built in a more robust manner. If the research bodies are small or relatively small, like the bodies of research we have in our countries, then the probability of dying is perhaps more. If you have many people to deal with these issues, you can have solutions like in Canada, where they have what they call science brokers, which are very well educated people that can dedicate their life to crossing these bridges. In the case of our teams, typically you have to do a bit of everything because we are far too few people in order to have people dedicated to that and not to science. The ethos, the cultures get a bit, they distrust each other. Have you heard a politician talking something bad about scientists? For sure you have. Have you heard scientists talking about politicians? Well, we talk also a lot of things that may apply in many cases, but not always. And we distrust each other. It's very difficult to collaborate when you have distrust. So in many ways, this is a traveling through terra incognita, or is an area that you have to build the ways and the manners along the way. And that's is a bit uncomfortable for many of us. These are many photos that you cannot see any of the details, but this is our first meeting in 2013 when we started this project. And we have typically at least 1 or 2 meetings per year. And over time, we have been meeting in person in one beautiful place in Chile somewhere, trying to discuss the science, what we are doing, how we are doing it, etc., etc. But yeah, this year we had to meet through Zoom. Trying to cross the bridge I was talking about. The first thing is that what we decided was to look for complex, scientifically challenging, interesting problems, but also relevant. That means that they had a relevance for policy making, for society in general, and looking at the elephant again. Identify smaller elephants that we could look at using our different expertise. In this team, you find sociologists, anthropologists, mathematicians, atmospheric scientists, atmospheric chemists, biologists. I mean, is plenty of different areas. However, this very elegant way of putting it, but the different ethos and ways to understand this epistemological diversity is not enough. You can have very different ways and ways even to communicate, and you need to have the diversity, but it's not enough. You have to have a common purpose, otherwise you don't get too far. So we had to put a lot of effort, a conscious effort, and a lot of work and reflection, learning, and nowadays we have a lot of professionalization of that. We don't do it. It doesn't happen are those like chemical reactions that need energy? Well, building inter and transdisciplinary research requires a lot of energy. The leaderships from the very beginning in the center have had, we have roughly a 50-50 balance between females and males. And the leadership has had quite a strong female flavor that has helped the balance between excellence and relevance. And we are still learning, but we have had some successes along the way, and we are still motivating or doing it. We think it's the way of the future. One thing I will stress, nevertheless, is that in order to make inter and transdisciplinary research, you need first to have a very strong basis in your own discipline. Otherwise you become something in between. So you need to have a particular expertise. So in addition to producing papers, which we have to and we like to produce, we have produced along the years a number of reports from 2015 onwards, addressing these elephants, these problems like the drought we have been suffering over the last decade or more, the Anthropocene itself and how it manifested in Chile, fires. You know, we had a horrendous fire, enormous fire by 2017, and we learned a lot about vulnerability and the climate relation to that. Air quality, which is also an issue of importance for us. We had looked into black carbon and the mitigation of black carbon as one of the decisions made by Chile in order to contribute to the Paris Agreement, and we provided the basis in terms of scenarios and projections about that. We have looked into the climate change law. We have been helpful to everybody in terms of producing the basis for establishing a good climate change law that is nowadays in these days being discussed in Parliament. Also, in addition to these many reports, we have many platforms showing data, making those data available for educational purposes, for scientific purposes, but also for the purpose of communicating with people, so people have access to the information. So in addition to those typical metadata or air quality data, we also have an observatory of the climate change law. We have nowadays an atlas of climate risk. And so we are working a lot over the years in that. And now we are looking into the governance of the elements, water, etc. Those are reports that are upcoming. So this has been a good way of communicating our science in a relatively more straightforward manner, not for scientists, but for policymakers and other parts of the community. One of those examples, and now I'm coming into more of the air quality issues, is a report to the nations that was launched this September, and in which the air quality is addressed. And in particular, the air quality issues we face every winter in central and southern Chile. You know, Chile is a very long country, starting by something like 18 degrees south down to 50. Well, we claim the Antarctic, but at least the continental part lasts until 53, 54 south. But we focus in this area between 33.5 and 45.6 degrees in continental Chile, where you can see every year a number of places with extremely bad air quality. Santiago has been already known about that, and I will talk a bit more about it later. But in general, central and southern Chile have a number of problems with air quality, in particular with aerosols, with PM 2.5, with particles. Here are 3 years of data, and this is the counting of passing the standard, the national standard of daily averages of 50 micrograms per cubic meter. And you see all of these cities surpass, in all of the years, they surpass this limit, this air quality standard. So we have quite an issue in terms of air quality. Several thousands of people die every year in Chile because of air quality. So it's something of relevance. And in many parts, including Santiago, to some extent, surprisingly, one of the culprits of this is wood burning. Wood burning that is used particularly in southern Chile, but to some extent also in central Chile, where wood that not seldom is native trees that are cut and used as wood for cooking, for heating the houses, etc. And so we have quite an issue of that, and this team led by Nicolás Uneus and Anaí Urquiza, an atmospheric chemist and an anthropologist, a sociologist, we're looking into that. And this is the video where it was presented to the Minister of Energy. And the Minister of Energy, because of this, is an issue of what we will call energy poverty, is lack of access to good energy sources. So among the many things that were done in this project, that is kind of a 2-year project with a strong interface with policymaking, an emission inventory, a high-resolution emission inventory was constructed, was built for, in fact, for the whole of continental Chile, but in here we show essentially central and southern Chile. And this information provides criteria pollutants, standard criteria pollutants, and its precursors, plus greenhouse gases. So it's made in a manner that is self-consistent and provides information for whole of the country. So far, what we had in Chile was, except for greenhouse gases that have a national and regional coverage, air quality had inventories for a city here, for a city there, but there was no uniform high coverage and high resolution inventory. And this was fed into a system, the WRF and Chimère system, an air quality model trying to simulate air quality, in particular PM 2.5, over central and southern Chile. And here there is a simulation showing the diurnal cycle of these sources. This is in winter, when the air pollution by particles is worst. So a full system was put into life, and in connection with that, in addition to that part, which is traditionally air quality or atmospheric chemistry, if you want, we also collaborated with people looking into paleo data, for instance, trying to reconstruct and reconstructing what we will call black carbon emissions since 1850. And you see this is for central Chile, and this is an indicator of pollution. So the higher, the more polluted the air was, and also the more activity in terms of black carbon emissions is supposed to be. And you see an increase along the years, and this is based on paleo records collected in central Chile. So it's also a way of understanding the processes and the changes that Chile has suffered over the last 200 years. There are similar studies for other indicators looking back into the last 3,000 years. So this is a recent picture of what's going on in terms of air quality in Chile. So, and that you could still think, well, this is an issue of air quality still, but we also looked into the social aspects, trying to identify the social cultural barriers to energy transition. Air quality has been dealt with, among other ways, by trying to change the way people cook and heat their houses, by providing better housing in the sense of transforming existing housing and putting some sort of cover in order to keep the heat inside the houses. But the question is that, or the thing is that it's not just a matter of saying, now from now on, you guys, you change your way of cooking and heating, because there are cultural barriers and people looked into those specifically. So first of all, the housing in Chile in general is quite precarious, and it's precarious in terms of isolation. So a lot of the heat that you produce within the house by typically, or in many cases, by heating, by using wood, is lost up into the air. So it's more that the birds enjoy the heat than we do, because our housing is still quite precarious. People are not rich people. Inequity here plays a role, and you see that there is a lack of access, both because other energy forms are not available, because wood burning and wood production is a business of its own. So it's the work of people. So people are not living their work because you tell them that the air quality is so-so. And also, if they wanted to change, it's costly. So it's not easy for people to access this clean energy. And when you cannot access that clean energy because of availability, and particularly because it's too costly for you, then that's called poverty, energy poverty. Using dry wood, which is better than using wet firewood, it's difficult. And these places are places where there is some rain, it's cold, it's snow, etc. It's difficult. People don't know how to use all these concepts of energy efficiency, which can be very much good for, or very good for people using refrigerators or cars or whatever. But when you are poor, energy efficiency is not your first thing in your mind, and sometimes the proper handling of these stoves is difficult. Also, there is a cultural thing. It's rooted to use firewood because it's multifunctional, because it provides you some autonomy. This part of these cities are far away from anything else, so you do not depend on others. You go and collect your wood, for instance. There is an enormous informality in terms of firewood market, and that makes things difficult. And it's very important for local economies, particularly in towns in southern Chile. The attainment plans that have been made for those cities, improving to some extent the air quality, but not reaching the expected results still, have had some participation. There is a law to open for participation, but this participation is limited in many ways. And society, it doesn't participate in those discussions on a what would I say, on an equitative manner. Some people know more, and when you know more, then you have an advantage, and the decisions are made by those who know more. So that's one of the other issues addressed by this report. And the other thing is that you make a plan, and then the supervision or the survey you make of that plan, whether it worked or not, is not always the strongest suit used by policymakers, and things, some measures are repeated year after year, but never, no one never says, you know, this hasn't worked. It's exaggerating. Of course, there is some evaluation, but it's not good enough. That's the point. We learned other things like the people that have been exposed to air quality are have been more hit by the COVID pandemic. If you live in a city where you are typically exposed to particles in particular, let me say that, then you are more prone to get sick with the virus because your organism is already exposed to very, how would I say, things that have altered already your health, irritating your lungs and your respiratory system. So you are more prone to the COVID, but you're also more prone to getting the normal flu. So we see and we saw an increase in the incidence of people getting sick, but also in terms of mortality. So there is an effect, there is this chronic effect of air quality that also played a role. And now we're still having issues with air quality and COVID over this part of the city in southern Chile. If I have time, how am I on time, Judith? I hope it's okay.
Yes, it's okay. You have plenty of time, Laura.
Good.
Don't
Good.
worry about it.
If you're not sleeping then, not sleeping, then I'll continue. Let me go now. Let me show you pieces of, let's say, more traditional science, but you will see science that has been made with the purpose of making, facilitating decision making. This is an old picture of Santiago, which I like very much. This is the airport. Some of the hills we have here, and here is the Andes, beautiful Andes with snow, and you can see the boundary layer. You know, we don't need to measure the boundary layer. We see it every day in winter. So Santiago has been for a long time, at least consciously for the last 40 years at least, knowingly under a cloud of particles in winter and plenty of ozone in summer. And Santiago is the largest urban area of Chile. It has roughly 40% of the population nowadays, roughly 20.2 million. That's the 2017 number. I think nowadays it should be something like 8 million people. But still 40% of the population of Chile is the part of the country where you have the largest fraction of the GDP, roughly 50%, and is a city with more than 2 million motor vehicles. In fact, that number must be now 2.5, perhaps 2.4, something of that order. So it's a highly urbanized area, the most urbanized area, and with a long history of air quality issues. And one of the things we looked into over the latest couple of years is the trends and also the role played by secondary pollutants, secondary aerosols, but also ozone. This is a picture showing measurements made downtown Santiago in a representative area for the whole basin of Santiago. Santiago is surrounded, you know, by the high Andes on the one hand, and a lower mountain range to the west, and on some hills to the south and the north. So we are surrounded by mountains and hills. That's one thing. But it's also a city with a number of activities, so there is lots of emissions in the city. Many years ago, by the late 80s, these were the levels of PM10 measured in Santiago. These are daily averages, so 24-hour averages. This is the same method all the time until 2015. Now we can extend that series a bit more. And you see, in those years, the average were kind of the levels you can see sometimes in Delhi, extremely polluted air quality in Santiago. PM10, so it is able to go into the upper part of your respiratory system. There was some conscious about that. Now in the 90s, people start doing stuff about that. And by 1997, we have our first attainment plan. And as you can see, things started improving. So PM10, in fact, has been lowered more than by roughly 60%. So there's been an improvement in terms of PM10, no doubt. There's another here in black, in dark black, you see PM 2.5, which we start measuring much later, of course. But still, here you cannot see clearly a trend, and I will go into more detail. But and the red line is the standard for PM10, and you see we were over the standard for many years, even until the late 2000s, and then we are still close but not above, and it's certainly it has improved, no discussion. The PM 2.5 is a bit more elusive, as I will show later. So first message is, yes, there's been an improvement in the air quality of Santiago over the last 30 years, no doubt about it. Nevertheless, Santiago, the city itself, since those years in the late 80s until more or less currently, it has grown in size by 1.5 times. Santiago in those years, when I was a student, many years ago, Santiago was a 500 kilometer square city. Nowadays is roughly 800 kilometers square. So it's been a city growing into different parts, essentially the parts that had to do with the best places for cultivating, for having agriculture, but that's another discussion. So the market decided the city would grow, and we grew, and we are a much larger city. The population has also been increased by 1.5 times since the late 80s. Vehicles, 3 times. We are richer now, so we buy vehicles. It's a status thing. The GDP has grown enormously. Poverty indexes have gone down. However, inequity has been maintained or even increased over the year. But in spite of that, the PM10 pollution has gone down. And essentially, there have been a number of new technologies. The fuel quality has been improved. Now we have sulfur in saying diesel is less than 15 parts per million. In those early days, it was something like, I don't know, 5,000 or 1,000. So it was a lot of work put into new refineries, into new technologies. 3-way catalytic converters in the early 90s, diesel particle filters. Fortunately, the fraction of diesel vehicles is still not too big in Chile in general, and in Santiago in particular, etc. But you see, in spite of a growing city, of growing urbanization, the air quality in terms of PM10 has improved. So there's been a success in terms of politics and policies, politics and policies, trying to improve that. We outgrew from a non-system of transportation to a system of transportation with a lot of trauma in between, because it was from one day to the other in 2007, but we have better buses, a better system of transportation nowadays, in addition to metro and subway, etc., etc. So in spite of a growing city, we improved the air quality. However, nowadays we have more and more personal cars, less and less public transport use. When I was a student, let me get back to that, roughly 80% of the people use public transport for going from one place to the other. Nowadays, that is roughly 40%. So too many people in normal conditions move from place to place in cars. And that's an issue. So there's been a change, a socioeconomic change and a behavioral change, which is very important. This is the rate of motorization for Santiago, estimated by some colleagues from the Catholic University. And you see here, over a part of the city, the motorization is comparable to Europe. So people, in fact, a bit less perhaps than Europe. You have something like at least 2 cars per person, you know, per every 1,000 inhabitants. In the western part of the city, you don't see that. If you look at emissions, say for diesel, of course, you see a pattern that resembles this distribution, a very inequitative distribution of emissions, etc. Also, if you look at the green areas in this part, which is, by the way, the wealthy part of the city, it's quite green. It's quite nice with trees, etc., etc. A lot of volatile organic compounds also being emitted, but let's keep that for a while. So, and here you don't see much of trees. Kids grow in rather gray areas, and there is a terrible exercise or demonstration of that. If you ask a kid over here to make a drawing, they will make a drawing with very dark colors. However, these kids will make it very colorful. So the city is been changing, is unequal, and we have reached a point where technology changes are not enough. So we need to think in terms of the governance of the city, and atmospheric chemists do not usually know a lot about the governance. They have to learn about it, and they need sociologists, economists, I don't know, lots of people, even politicians, to learn about how the city is governed and how we can participate in being a part of the city. How do we assess these problems? How do we approach them? And we learned in a paper that we published in 2018 that the changes in behavior are necessary. So we have to go beyond the knowledge of engineers and atmospheric chemists, and we need other knowledges, other experiences, and even more important, we need the concurrence of the people to change those behaviors. And how to do that is a good question. Now, finally, let me go into PM 2.5. This is the series for downtown Santiago again, and you can see that PM 2.5 has also changed over time. This is the same station in downtown Santiago. Here is the daily standard of 50 micrograms per cubic meter, and this is the annual standard, 25. And you can see we are not in a good position in terms of that. But if you look closely, then you notice that the first period here from 2001, 2008, 9, roughly, you find, yes, a decline in the concentrations over time. And it's a quite substantial decrease of something like minus 8.7 micrograms per cubic meter plus minus 3.4. So there is a significant and substantial decline. However, if you look at the second period, you start to see a reverse in this trend, and you see a growing in the marginally significant, but still a growing trend in PM 2.5. So we wonder, why is this changing? We still have attainment plans. What's going on? So we start thinking, well, if mobile emissions are declining, which is something we have done a lot, the cars we have here are in general very new, they have catalyzers, they have particle filters if needed, etc., etc. So if the emissions of mobile emissions are declining, which is the data we have, but NO2 is increasing, and if you're doing a chemistry course, then you are thinking already, maybe ozone is involved, maybe the oxidative capacity of the atmosphere is changing, and maybe it's secondary aerosols. And in fact, if you look into data from satellites, you see a trend in NO2 that is increasing substantially, something like 30% since 2005 and 2015. That's quite a lot, plus minus 16%, but still is a substantial increase in terms of NO2. If you look at the in situ data in the stations we have NO2 data, you also see this increase is a bit smaller, but still roughly consistent with this one. So we see a lot of growth in terms of NO2, in spite of mobile emissions, which are declining. Then you look into the other data you have in the network. This is Santiago. This is the picture of Santiago, a simplified picture of Santiago. And here are the different stations where a number of criteria pollutants are measured. It is a rather, is public data, is roughly good data, particularly for particles. That's good for gases, but that's another issue. But the problem is that we have very seldom a speciation of our aerosols. And that means that we cannot really say much about the properties, whether it's primary or secondary aerosols, or even which are the optical properties. And there are no measurements, no regular measurements of volatile organic compounds. So how do we characterize secondary aerosols? Well, in lack of a speciation data, what you use is proxies. And in fact, there is an old work, now relatively old, from 2007, I think. Yes, 2007, by Shuhuan-Xin Chang and Chung-Ti Li from China, who also probably, they didn't have all the fancy instruments to characterize aerosols, but they thought about the old knowledge regarding photochemistry, and they thought perhaps there is a way of using gaseous indicators like ozone and CO in order to establish something about the fraction of secondary aerosol. And in fact, in general, you produce more secondary aerosols the more ozone you have, because the more ozone you have is the more photochemical activity and the more oxidation of VOx and many other things that will occur in the atmosphere. And also the more oxidation of inorganic matter. So, and you can use carbon monoxide, which is essentially produced, in the case of Santiago at least, is essentially produced by cars, and which is, so, and cars also produce particles, and you can correlate PM 2.5 with CO, and if that correlation is very good, that means that they have the same source, and that means that essentially what you're looking at is primary PM 2.5. But when that correlation worsens, then probably there is something else explaining the data, and that explanation is probably secondary aerosol formation. So something is happening in the atmosphere, producing some extra PM 2.5 that you cannot correlate with carbon monoxide. So I had a very good student, and I told him, why don't you look at this? And we did. And we started by characterizing this oxidative capacity. At the time, we couldn't measure OH, but we have ozone and NO2, and that's OX, which is a part of the oxidative capacity of the atmosphere, and is a good indicator of that. And in fact, we see an increase in the oxidative capacity of the atmosphere in this OX, in the different stations, but particularly over Eastern Santiago. And mostly in the wealthy part of the city. Ozone, on the other hand, is going down. Well, but we are still in a regime that is dominated by the superabundance of NOx, or fresh emissions of NO. So probably what we are seeing here is not a natural reduction of ozone, but more of a titration issue. And in fact, we see that NO is more than NO2, and we see an increase in NO2. So in fact, the oxidative capacity of the atmosphere of Santiago is changing over the years, and it's changing basically because ozone is being used to produce the pseudo-ozone, which is NO2. That's for the people working on atmospheric chemistry right now. And in fact, what we see in Eastern Santiago, this is the fraction of secondary material that is secondary, according to this estimate. And in the early 2000s, roughly 30%, 34%, there is a variance here over these years. But if you look at this fraction, depending on the annual basis or a warm season or the cold season, you can see that in general, in this part of the time, over this period, you could see an average contribution of secondary aerosol, according to this method, of roughly 30%. But nowadays, in the second part, from 2009 and forward, you see a larger fraction, a fraction of about 46% on average, which, of course, in the summer season is higher. You can find that roughly, or you can estimate that roughly 60 or 70% of the aerosol we're looking in the eastern part of Santiago is secondary. It wasn't emitted directly to the atmosphere, it was formed in the atmosphere. And when you look at the trends and quantify those trends, these are the trends for the different periods. You see the trend in OX, the trends in PM2.5 as secondary particles, and the PM2.5 total. And you see in the first period, you had a declining trend of particles, of fine particles, and now you have a trend that's going up instead of down. And the fraction of secondary material is higher. So we have an issue of PM2.5 that is secondary in the eastern part of Santiago particularly, but not too low in the eastern part. It's still, we have something like 30 to 40% of contribution of secondary particles. So it's not longer a matter of addressing sources, primary sources, which we have dealt with them to a large extent, but also to think about photochemistry. It's much more difficult, but the policy has to refocus into secondary aerosol. And these changes in aerosol and secondary aerosols also make you think in terms of ozone. I'm not showing the results for that work, but we have also seen that over eastern Santiago, we see an exceedance of the standard of 61 ppb of ozone regularly and over the last 20 years. So we are moving into a more oxidative atmosphere. Well, this is the trip I had for you. Let me summarize part of the things I've been talking about. First, regarding the Center for Climate and Resilience Research. This is a center of excellence with a growing, diverse community who has been able to crossing inter and transdisciplinary bridges or boundaries as it's required during or in the Anthropocene. In that capacity, CR2 has contributed to deepening our understanding of climate and resilience in Chile, but also to contribute to the public discussion and decision-making. An example of that is the recent report on the Earth, on the air we breathe, that has assessed the role of energy poverty on current and future air quality. And in that work, yeah, you can look at it, it's online. you can look at the recommendations provided as well as the data collected. There is a repository and a platform to look and access those data. And now we are moving, we are trying to conquer the world in a bit and looking more beyond our political boundaries and trying to look more into more collaboration with Latin America and the Caribbean, of course, and the Southern Hemisphere in general. So anybody looking for a postdoctoral position, contact us, that's to begin with, but also in terms of exchanges and common learnings. That's kind of an invitation. And the second part that I talk about air quality, yes, policies and technological changes have been successful in reducing PM10, not so much for PM2.5 and photochemical pollution in general, for ozone, and chronic health impacts. There is also so much one can learn from top-down policies and behaviors must change. And in order to do so, is key to address mobility in a more complete manner, and also to include the participation of people in those decisions. And in general, we find an increased fraction of secondary aerosols consistent with an increase in the oxidizing capacity of the atmosphere. So, obrigada, gente, and thank you very much for your attention.
Thank you very, very much, Laura. Muito obrigada. Really amazing talk, excellent, and you speak in such a clear way in English that I hope that our students were able to follow. We are not having so many English talks here in our seminar series. I would like to see that changing, especially now that it's more easy, that it's easier to invite people from far, far away, right?
A próxima vez poderia, não sei, ensaiar de falar português, mas não falo português, não. E em castelhano poderia em castelhano.
See, we discussed that actually, Laura. I would ask you to speak in Spanish, in Castellano, sorry, or in English.
Castellano.
Yeah. But yes, but we were worried that in Castellano you would speak very quickly.
Quicker.
In Castellano.
Which is even worse, I know.
And then we said, well, you know, maybe it's better in English. You will speak slower, and it's also the official scientific language. So let's.
So far, yeah.
So far, okay, yeah.
Because next round is Chinese, you know.
Yes, but probably not for my generation.
Not mine either, but the students for sure.
Yes, that's true. But anyway, I'm still traditional and incentivizing them to learn speaking English. But anyway, we have a lot of people here with questions, and thanking you for the excellent talk. And I would like to make a comment and a question at first, and then I will go over to the questions that we have here via YouTube, the chat. So Lara, I was really amazed by all the activities and the strong transdisciplinary focus that you have with the Climate Resilience Center. Lara, actually,
it's easier.
Maybe stop your presentation.
Oh yeah.
I will start.
Okay, yes. Perfect. So you know that I have, I don't know if you have came across the name of Klimapolis with K.
Yes.
It's a German-Brazilian initiative in which I participate also. It's founded by the German Ministry for Education and Science and Education, BMBF. Mm-hmm. And it started with a project in 2018, a 5-year project. So we are kind of in the middle of it. We're supposed to have the kickoff meeting here for the northeast of Brazil, here in Natal at the university in May this year, but then the pandemic came, and anyway. you know the rest of the story. And so this is also a very transdisciplinary research program, and it's meanwhile has been expanded to the Climapolis laboratory, which is supposed to be permanent. It exists virtually at the moment, with two co-directors, Anita Engel, from Social Sciences Professor of the University of Hamburg. And here from the Brazilian side, our director is Rita Inui from IAG at USP. And yes, and we have meanwhile we have a management committee who decides on stuff, and I'm also participating in this part. And our idea is now our vision is to form a center, a global center. And I see that many of your goals at the Climate Resilience Center are quite similar to what we are looking at. We are focused, we have one restriction that we want to focus on urban areas,
okay,
on metropolitan areas. But apart from that, it's transdisciplinary in a very similar way, focusing on climate, focusing on air quality, hydrological modeling. Here at all the Brazilian coast, all the big cities that we have massive challenges with coastal erosion, also in the urban metropolitan areas, and this affects the life in the cities a lot. And some, how do you say, some economy sectors. And so, yes, so this is the background information, you know, so that's why I'm lately very interested in this transdisciplinary work and trying to widen our minds. And as you say, it's a challenge, it's more difficult. So I feel that many people still do not want to look into this interdisciplinarity and transdisciplinarity. And the main thing is a communication issue between the different areas, and then not only between the different academic areas, but also, as you said, with politicians, and they have the same problem with us, of course. No, so my question to you is, what is the CR2 doing in terms of metropolitan areas? What are the main foci?
One of the things I didn't show was a work that's been led by Anaí Urquiza, who is a sociologist, anthropologist, and one of the things is try to characterize vulnerability to different threats. One is fires, the decline in precipitation, so drought, but also trying to combine the different threats, including air quality. So how to have a good proxies for being able to characterize vulnerability, and thereby also trying to characterize the capacity, the learning capacity, and the capacity that has the society to change and face those challenges, plus trying to define or understand the key steps in trying to define different governance. For instance, Santiago has a tremendous, horrible issue with governance. We are still governed by small, what we call communes or districts that not necessarily talk to each other. There is nothing like a mayor over the city now. In fact, on the next months, we are going to be electing for the first time something called governors that rule over an area, but this governor is competing with a very centralized way of looking at governance. So there is some issues. So they will have not so many rules and what I would say tools to work with, but there is a change in that, and we need to work on that. Participation of people in general is low, is typically a participation of experts. If any, it's of experts and or people that have a particular interest. But in general, there is a lot of work to do in terms of participation of regular people, the people that actually have to decide not to take the car and go to, or have a city that is good in order to think of the possibility for people to work closer to where they live. Generally here, people cross the city of Santiago over several tens of kilometers, which are not really feasible by biking. I mean, it's the wealthy part of the city that can use the bike in a proper manner. So coming back, so one of the focus of the foci is looking into governance, vulnerability, and the overall concept of resilience, of urban resilience. There are as many definitions, I will say something not politically correct, as many definitions as there are anthropologists and sociologists. Everybody has its definition. And one has to be very careful in adopting sometimes some of the concepts that have been developed for other realities that are different to those we live here, you know, in our countries. So one has to be careful. We have a paper in Earth's Future, Future Earth, Future or Earth's Future? Earth's Future. Earth's Future is the journal.
Future Earth.
No, the journal is discussing this conceptualization of resilience and vulnerability. Also, there are looking, of course, into air quality, present and future. We have to continue. We are working in modeling these secondary aerosol parts. Another thing that is an opening for us for including the urban dimension has been the carbon, the black carbon, the introduction of black carbon as a mitigation purpose in Chile for the Paris Agreement, because that allows us to address the problem of energy poverty, which is so substantial to air quality issues in central and southern Chile. So there are a number of issues we are dealing with, but I would say that essentially addressing vulnerability, trying to look which are the impacts of the city, within the city and outside, how is the governance of a city, of the cities, and yeah, those are the things we are looking into.
Yeah, so that's very, that we have really in common at Climapolis. It's so far still only a German-Brazilian initiative, but maybe in the future when we are able to establish the center, it would be really interesting to set up some collaboration, or we should talk.
Of course.
It's really the same idea, I guess. So there are some questions from students. So we have here a question from Edicle Fernandez, who's a PhD student of our program. He says things such as climate change and pollution are already more accessible to society. However, when working with more complex or specific topics, there is a difficulty in making those more transdisciplinary. So how to make yourself more transdisciplinary when working with very complex topics such as data assimilation? How to talk to social scientists and make complex topics more accessible to society?
There is a saying in Chile, in Spanish, in Chilean Spanish, that says that the devil knows more, not because it's the devil, but because he's old. So there is I think in the beginning of a career, it's good to have a knowledge of what is going on in terms of interdisciplinary and transdisciplinary research. It's good to participate because that's the way of learning. But probably the first focus is to be clear about what you want to learn in terms of your own discipline, about your expertise in your first part of your career. But the older you grow and you want to make a difference beyond publishing a paper, then probably you are more in a space of trying to do these things. And there are also personal things. I'm the daughter of a social worker. So for me, society was never far away from my picture, or politics for that matter. So there is a will and some experience with that didn't make it too difficult for me to talk with people who are different. I was in Sweden. I was exposed to systems and systems of systems and complexity. So then if you understand that the world is complex, then you are humble enough to see that there are other people that have expertise that you don't have. So you have to talk to other people. So I don't know. But there is also, my eyes can be very bright at some moment of nerdiness in front of a computer modeling. I had a ball last year when I went for a visit to Norway and started playing around with the model again. I was so super happy to look code in Fortran, and So you have both. You have you have to have a strong side of you that is nerdy in your own thing, but you can start making this crossing and bridging over time. And it's a matter of experience, and it's also a matter of will. What do you want to do? How do you want to make your difference in the world?
Yes, and there are some very important sentences that you said. I think that we should people, especially when they're in the early career, should think about and consider. I think that this transdisciplinarity and the need of it has evolved in the last decade a lot.
Yeah, and let me tell you. Yes. Just one detail which is important. If you want to publish your interdisciplinary research, it's more difficult because journals are monodisciplinary. So you have to have a background already in order to try that. I mean, it's super nice. It's a nice experience, but I wouldn't recommend to anyone to just do interdisciplinary research. Besides, you need disciplinary research as well. I mean, you cannot, if you want to understand secondary aerosols, you don't discuss the very detailed part with a sociologist. It's pointless. And they have their own stuff. Yes. But it's the common problem that makes you collaborate.
Mm-hmm. And yeah, that's fantastic. So well, define early career. You mean someone including a first postdoc, maybe?
Possibly. Yes. Possibly.
Okay, then this means if you have, do you just have postdocs at the climate at CR2, or do you also have master and PhD students?
Yeah, but all of those.
But they do, then the master and PhD students do more disciplinary work.
On their own, they also contribute to this and say the work that was done by this student, by Camilo Menares, about secondary aerosols. Yes. He does that. It's very disciplinary. Mm-hmm. However, he learns that that is made in a context, in a bigger world. So he is able to look into the whole picture and not just secondary aerosols.
Yes,
that's the thing, and also it's a matter of will. Probably it'll become easier because it's necessary. So science and science institutions are also evolving. But yes, such is life.
I even believe that nowadays there are already some journals coming up that have a
yes, there are.
disciplinary approach. I think they realized that there is a demand for that, right?
Yeah, one of the things we published about the Anthropocenes, we published in Elementa. Elementa at the time wasn't recognized by, how do you call it? One of the enterprises, Reuters, the ones with the ECI establishment and counting, etc. is whatever.
Springer?
Huh?
No, Springer?
No, Springer is another thing. It's that's Reuters.
Oh.
I'm missing one word, but doesn't matter.
Okay.
Now it's a well-recognized journal with a good number, and but at the beginning it was quite a discussion within the center whether it would be a good idea to publish in that journal, because, well, what we had at hand was that the people that were editors for that journal were good scientists. Not any classification on any ranking on any numberology thing, but it's more difficult, still more difficult, but it's amazing what you learn.
Yes. I'm finding that out since 2018, since I'm interacting with the Climapolis community, and it has a fantastic experience. That's for sure true. So I have a question here from a colleague who's a professor here at UFRN, Venerando Amaro, and he says, thanks for your excellent presentation. Could you please say a few words about CO2 activities in the coastal zone and land use changes? I think it's two different.
Yes.
So.
Yeah. Well, the coastal zone per se is one of the research areas. We have one on resilient cities, another on water and extremes, another on land use change, another on governance, and another of coastal zones. So there is research. The group was essentially a group working on biogeochemistry in the upper ocean along the Humboldt Current, a very active and very good group. Now has also a meteorological flavor in it, looking into, for instance, aerosols in the coastal zone. And now we are starting one of what we call integrative issues, and it is about algae blooms, hazardous algae bloom, HABs. So they are looking into that with this integrative perspective, in which they are looking into the livelihoods of fishermen and fisherwomen along the coast, the legal issues that had to do with the governance of the coastal zone, because we have a discontinuity in the management. The one point is policemen, the next is the people in the Navy, etc., etc. So they are looking at different issues in addition to the algae blooms and the changes we have looked into, we have seen rather in the upper ocean and even in the deeper ocean along Chile. So yes, there is a good group working on it, and the first leader was Laura Farias, a biochemist, and now is Martin Jacques, a climatologist.
Mm-hmm. And what are the main issues in Chile on the coast? I mean, we have coastal erosion issue very strongly along the whole coast here.
Yeah. Sorry, we have surges. I mean, the winds are changing, so we have more and more of surges, and our harbors and stuff have been built in such a way to receive waves from one side, and then they change, and then you are very vulnerable. There is a disappearance of the beaches because of the changes in this type of thing. in general, Chile has a quite abrupt geography and topography. So except for southern Chile, we don't have too much of a problem with sea level changing. In southern Chile, there is a problem of that. The other thing has been the algae blooms. We have a quite active industry cultivating salmons, and that is expanding, creating a number of issues and dependencies in society and in the coastal zones. We have had disasters with tons and tons of fish lost and dead. I mean, we have had, so it's a quite complex area. There are other groups in Chile, of course, working on different issues, the deep ocean, the oxygen minimum, and all those things. But the group at CR2 is more focusing on exchange of greenhouse gases, N2O, methane, and even to some extent DMS, etc.
Mm-hmm. Yeah, it's a very long coast, right?
Very long.
Very different properties, probably.
Yeah, there are different properties and different communities as well. Yes. I mean, even we go into Patagonia and Antarctica if you
yes, right.
want.
Different climate zones and issues, probably.
Yeah.
Yes.
So, but there are several groups working on that.
And in the South, Laura, where you say you have to sea level rise, is it actually related to global warming, or is it associated to?
There is a risk. There is a relative higher risk. It's not too big an issue in general for Chile, but this is relatively higher over southern Chile. If you look into the projections and the decline nowadays, the instability of Antarctica is worrisome. So, yeah. And Chile is a coastal country, at least continental. Well, on the others are islands. So there you go. We are a coastal country by definition. But apparently not all the time we are very conscious of that. And for instance, the governance of the coastal zone and thereby the decision making over the coastal zone, to some extent is a bit back in past. It was like in the 1800s or so. The decision making is very old fashioned in a way. So there is a need of changing paradigms and definitely incorporating more science and changes in that.
We have a question from a former student of ours, meteorologist Felipe Medeiros, and he's asking what is the principal challenge of the center, what the center is facing when discussing or communicating climate change with the decision makers.
Fortunately, in Chile, at least the discourse, another thing could be reality, but the discourse has been quite unified across political sectors. So we have talked about climate change with President Bachelet, let's say more to the left, and even with President Piñera, more to the right. The climate change law is one of the proposals of Piñera's program. And there is, as I said, there is a legislation being discussed in Parliament right now. And we are acting as kind of a scientific board, I don't know how to call it, in between government, in between the executive power and the parliamentary power. So fortunately, there is a general consensus, I would say, in Chile that climate change is an issue of concern for us. And we have to do things about it. Sometimes how to do it and what to do differs a bit. for instance, like everybody else, we have gone through this economic crisis due to the COVID, and the formula that people are trying to apply for recovery is, at least in my opinion, not green enough. We can do more of that, and there are voices that say that we have been too forward in terms of climate. There was the issue of having the COP, or potentially having the COP25 here, that forced also a number of decisions, which is good. Serendipity sometimes plays in favor. So I would say in general, it's been relatively easy to get to the political power. So in that sense, it's been not too difficult. I mean, we are not dealing with a person like Mr. Trump to make it. I won't put the other one that we know about.
Yes.
But Mr. Trump, we're not talking with someone who doesn't believe in science. They have different approaches to solving the problem, let's say, but they are aware of the problem.
Mm-hmm. Yes, perfect. I have also another question from Edicle Fernandez from our program, and now it's more specifically about disciplinary science.
Yeah.
Interested in your very high resolution emission inventory.
Yeah.
And he asks, what is the way to go to develop such an emission inventory on high resolution? Because in Brazil, it's still a huge problem for us that we start using here for the Northeast something like EDGA that was never validated for the region, and God knows whether it works or not.
Yeah.
So it's very hard to publish something with air quality models here over the Northeast until now. So it's very challenging and needs a lot of different inputs. So how to tackle this to achieve such an inventory in Chile?
Well, one has to recognize that Chile has been concerned with air quality for quite a while. So there are within the ministries, for instance, there has been some work covering Chile already on vehicular emissions, mobile emissions. So we had already a basis. Part of the people who work in that are part of the center. You all know perhaps Mauricio Oces. You knew him some time ago. And he has been the leader for mobile emissions. Nicolás Uneus, together with people in economy and sociology, in fact, they looked into the data for creating an emission inventory for firewood and distributing that according essentially to housing statistics and population. So essentially quite a lot of work, I would say. We still have an enormous problem in terms of emission factors. When you try to calculate emissions for particles emitted from wood burning, you have essentially 2 orders of magnitude have been used in different studies. And we are adopting so far a number from literature. But there are uncertainties regarding activity data as well as emission factors, but emission factors as well are extremely uncertain. And there is a need of working more into defining those factors much better. Industry
experiments? You mean like doing
measuring the actual in real conditions, because these stoves are managed by every person differently, so you have to be very careful in how you characterize that. And the third sector that was included is the industrial sector. The industry reports their emissions. They have to report their emissions. But still there is a need of work in terms of validating those databases, but that's the work that's been done. And we are also using proxy, say, for using NO2 for validating emission inventories, etc. So there is the building up, the bottom-up construction of inventories, but also the work of validating that work. Weak parts are biogenics. No idea. Well, just you have an idea. You always have these global inventories. There's been a work. Nicolas also published some work comparing urban emissions to global emissions over South America, which is of interest, including Sao Paulo. In southern Porto Alegre, possibly. So there is some work already done in that respect.
Yes, we still have a lot of work ahead here in Brazil.
Well, perhaps one advantage we have is this is a centralized country. So ministries collect information. And our statistics, except for the last but one census, has been in general quite good. But so there is a basis to start from. And the greenhouse gases emission inventory for Chile is rather good. It's very good. It's been a lot of work put into it from the Ministry for the Environment.
But it's not related to the reactive air pollutants.
No, but now they have to produce the black carbon emission inventory. Chan chan. So, and so the 1 kilometer it looks like tremendous for them, but on the other hand, doing that work on a regular basis is tremendously useful for many purposes, for policy, but also for modeling and science in general.
Of course, yes, perfect. Lara, I have a question. I was wondering when you were saying that people are more and more using individual cars in Santiago.
In Santiago.
Yes, and I remember when I was in Santiago that we have a very nice metro, which is something that you do not have here in every city. I have it in São Paulo, but for example, in Natal, we don't have it. And it seems to me that the public transport compared to where I come from in Brazil was quite good, actually.
Yes.
And so does it mean that the public transport got worse, or what is happening? Why is that happening?
One of the things that happened since you were here is that the metro lines were extended. But the metro lines...
Which is good.
But the metro lines, building metro is very expensive, particularly in a country where the earth moves quite often. So you have to build in a very expensive manner.
Right.
And so there is an economic boundary to how many lines you can build. Okay, but so we have a good network, and the coverage of that network grew towards the people that needed it the most. Poorest people. Good.
Yes.
Excellent too. So more people started to use the metro.
Yes.
So from roughly empty metros we had a few years ago, 10 years ago, now we have metros that are more approaching, not Tokyo, but it's crowded.
Nobody pushing you into
No, but there are some conflicts in the morning before the pandemic.
Yeah, I remember that was already 10 years ago. That was,
the peak hours can be difficult.
Exactly.
So there is a limit. And the one thing that has happened is that, yes, we got richer, and the network of buses still has some limitations in some parts of the city, particularly over poorer areas. And people, and perhaps the real issue is that people live in one place and they work exactly on the other side of the city. So again, it's a matter of governance, of decision making, how you build your city. Because, I mean, people are not going to use a bike for riding 30 kilometers or 60 kilometers a day. An old grandma, you know, it's going to be difficult. Probably she lives in a part of the city that security is so-and-so, tricky. So bikes, which has grown a lot over the last few years and last 10 years as well, still is more for middle upper class, preferably, except when you go into the rural areas. So, I mean, there are more to say about, but the transport system, and again, the technologies have a limit. You need to change actually the city. The kids, we have a very stupid system still with a lot of private schools, and kids move around for tens of kilometers every day.
Wow.
And so one of the pushes for mobility is kids and schools. And then you have to make that education is better everywhere, so people can go to the closest school by walking, which is the normal thing.
Yeah.
Etc.
It's a good point. I didn't think about the school issue, but it's certainly an important point. Yes. Finally, Laura, I have a question. It might seem a bit off topic, but it is important to us. So I was really amazed by the fact that the staff at your center is 50% composed of women.
Yeah.
And it made me very happy to see that. It's amazing. But how would that work? Because when I see in Brazil, there is no policy whatsoever in this regard. And we have for public servant selection processes, but there is no law in any sense to make sure that you have a good equilibrium of women and men at a department or at any workplace. So how does that work in Chile? Were you able to do that? I'm really curious about that.
No, Chile has also problems of discrimination. We also, in general, women earn less money, are less represented, blah, 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 in general. However, in the case of the center in particular, I guess it was serendipity. I don't know. I got the I don't know how to say. I got the leadership of these things at the beginning. So I naturally talked to men and women. And the first board of the center was 3 women, 2 men. And from the top down, I guess, was an interest of that. And also, Maisa Rojas, who is the current director, a climatologist from the same department that I am in geophysics at the Faculty of Engineering, or Science and Mathematical and Physical Science, but also a Faculty of Engineering, had from the early 2011, more or less simultaneously, quite a lot of discussion regarding discrimination, and having started a policy by 2013, more or less simultaneously, a positive policy for integrating more students and also more professors. So we have, in fact, a positive discrimination policy at the faculty that allowed us to grow from 16% of students, female students in this first year, to roughly 30%. Because, and it's only, in my faculty, is only like 800 students every year. And we added the next 40 girls to come into the system. And that motivated girls that would come in any way, because they had the national tests with very good grades. to come in. And probably this thing that we were discussing in the faculty propagated as well to the center. We were, myself, we were part of that, and we promoted that, and we still keep an eye on that. So yes, and it's definitely better. I mean, when you take into account the other 50% of humanity, you definitely get a more diverse approach to things, and it's good. And it's really good for both for us and for our male colleagues.
Yes, exactly. So no, it's really fantastic. So it's not like a incentive of the government really, or some law, but it is actually a voluntary engagement in
but you know, it has happened. I mean, when I guess that the thing is, when you have examples of women in leadership, then other women try and have the courage to go there. Yeah, yes. They feel attracted to those positions. Like men in, say, in infirmary or some other profession that is women dominated. But if you see someone there that looks like you, you don't feel so awkward.
Yes, I see. No, that's really, it stood out, and I find it really remarkable. So congratulations on that. Fantastic.
Thank you.
Hey, Laura, we don't have more questions here. Do you want to make any closing remarks?
Well, just to open the invitation to people, I certainly see more of a connection. We are looking, our aim is to make CR2 not just a 10-year project, but to make it really a player for a long time. So I really hope that we will go beyond. I'm pretty sure, in fact, that we will go beyond 22. And so please contact us. Let's exchange. When I met you, you know, in this project, how do you call it? Science, whatever, because Brazilians said one way, we said other thing, and Argentinians, of course, said something different. Yes. In that project, in Inter-American project, I think we made a difference as a region, and there is a power of working together within the region, and we want to work more and more with the region, and so we are looking for exchange of students, of researchers, of, you know, we have many issues in common, and we can learn from each other, no doubt. So we look forward, all levels.
Yes, these are perfect final words. Laura, thank you very, very much for your
Muito obrigada.
Motivation to participate here in our seminar series. It was you're a very exceptional guest, so we're very happy.
Thank you.
that we could make it happen. And I hope to talk to you soon about more interactions from the different institutions here in Brazil with your center, and also via maybe the Climapolis. Yes. So thank you very much. And I would also like to thank Aguiar, who's our IT expert. He's the boss of our IT section at the Center for Geosciences. And he always makes sure that everything runs here. And he has been doing an excellent job on that. So thank you very much. And just for the remaining people who are assisting, I just want to announce that next week we will also have an invited speaker from abroad, which is Ilan Koren from the White Institute of Science. Yes. And he
go for it.
Obviously, he will talk about clouds, cloud aerosol interaction, and cloud ecology. So I hope that you will be with us. The talk will also be in English. There is not even an option to do it in Spanish, maybe in Hebrew, but I think this would not be helpful. So we will stick to English.
No, and he's an excellent scientist and a very nice person.
Yes, that's
very good.
Very true. Yes. So thank you very much. And Laura, sorry. And see you all next week, next Friday.
Ciao, Judith.
Bye bye. Ciao.
Nos vemos.
Bye-bye.
Chao, chao, chao. Gracias.
See you.
Chao.
Ciao.